Hello, good morning everyone.
Good morning, ma'am.
So today we are going to continue our discussion related to ER diagrams. In the last session, I have introduced you with the concept of weak entity sets. So we are going to extend our discussion further with respect to weak entity sets, and also we are going to look at few extended features of ER diagrams, and one of such feature is the concept of specialization and generalization. So we are going to focus upon this concept as well. So let's begin with weak entity sets. So in the last session, we have seen one example demonstrating weak entity set, and we also defined what is meant by weak entity set. So weak entity set is the entity set which is not having its own primary key, but it depends on some identifying entity set or some strong entity set for its existence, right? So we have seen one example. Let us once again go through that example, and then we'll focus upon few more important concepts related to weak entity set. So we are talking about our university database system. So in university database, it has been mentioned that the university has various courses, and university maintains a list of all sections those are taught under these courses, and each section is identified by a course ID, section ID, year and semester. So this is what we are supposed to model now using our ER diagram. So no doubt we can identify here that course is one of the entity sets that stores the information related to the courses. But in addition to that information, what we are supposed to store, we want to maintain a record that contains whichever are the sections those are taught under every course. So obviously it indicates that every course is partitioned into sections, say section 1, section 2, section 3 and so on. So every course is associated with several sections. So no doubt every course will have section 2 and so on. Is that correct? So if I want to identify that this section 1 belongs to which course, then obviously I need to take help from this entity set course, right? So if this is the situation that we would like to model, we are having this kind of ER diagram. So what we have? We are having this course, which is the entity set as shown here. So this entity set course is having attributes like course ID, title of the course and credits. And as I mentioned, what we are supposed to store, we want to store the sections taught under each course. Sections taught under each course. And it has been mentioned how to identify that section. So this section belongs to certain course, and we are identifying this section with these three attributes: section ID, semester and the year when that course section was taught. Okay, so let me give you clear idea what actually we want to store, right? Say for example, in this course entity set, what we are storing? We are storing course ID, title of the course and credits. So we would like to store the data something like this. So we are having a unique course ID, title for that course and the number of credits. So look at this particular instance of my database that we are having these several courses, those are being taught. Okay, but every course, as stated here, every course is having its sections. So say for example, this course ID BIO101 is having section 1, 2, 3 and so on. Similarly, if I look at this another course, say CS101, then this course is also having section 1, 2, 3 and so on. So we need to maintain the information like under which course, which are the sections, those are being taught in which semester and in which year. Right? So we would like to store something like this. See here, I am having course say CS101. So belonging to this course CS101, we are having section ID 1, section 1. So this section 1 is taught in semester fall 2009. Also, the same section of the same course is also taught in spring 2010. So if I'm storing this information in some other entity set, I need to distinguish these sections from one another. So if I only use this section ID to distinguish one section from another, it may not be helpful for me because the same section belonging to the same course can be taught in various different semesters as well as years. So I am making use of these three attributes, section ID, year and semester. Those are distinguishing the sections of the same course from one another. Right? And as I mentioned, these sections depend upon another entity set, that is course. We say that this section is the weak entity set. It is not having its own primary key, but it depends on some other entity set for its existence. So section ID depends upon some course ID, right? Or the combination of section ID, semester, year actually depends upon some course ID. So always to identify which section is being taught in which semester and which year, we need to take help from this other entity set, that is course, right? And that is why as existence of this section, which is the entity set we have depicted here, the existence of this section entity set always depends upon some other entity set, and that is why we say that this section is the weak entity set. And in ER diagram, the weak entity set is depicted like double rectangle as shown here. And obviously in between these two entity sets, course and section, now we should have a relation, right? Because these two entity sets are now related. So we are having here the relationship between course and section, but this relationship is now the relationship between course and the related weak entity set, and that is why this relationship is not the normal relationship set, but this relationship set is known as the identifying relationship set and is depicted in ER diagram using this double diamond, right? And always this identifying relationship set is having the cardinality 1:n. 1 towards the identifying entity set and n towards the weak entity set, right? And always this weak entity set participates in identifying relationship set with total participation. Are you getting me? Yes.
Yes, ma'am.
Yes, ma'am.
Fine. So this is how we can model this given requirement using ER diagram. Okay. Now let's once again go through few important key concepts related to weak entity set and few definitions related to weak entity set. So this is what we have seen right now. Okay. And let us now list out few of the important definitions and the concepts, key ideas under this weak entity set. So an entity set that does not have a primary key is referred to as weak entity set. So as I stated, this weak entity set section is not having its own primary key, but we can create a primary key for this weak entity set by making use of the identifying entity set associated with this. Okay. So how to define a weak entity set? The weak entity set is the entity set that do not have its own primary key and it depends upon some other entity set for its existence, right? So the existence of a weak entity set depends on the existence of an identifying entity set. So this course is the identifying entity set. So the existence of this entity set section depends on this entity set, other entity set, that is course. So the entity set on which the weak entity set depends is known as the identifying entity set. So in this case, course is my identifying entity set and section is my weak entity set. Right? Now, the identifying entity set and the weak entity set must be related with some relationship. Okay? And as I stated, this relationship always is having the cardinality that is 1 to many. So this relationship set is always having the cardinality 1 to many from the identifying entity set to the weak entity set. So towards identifying entity set it is 1 and towards the section entity set, towards the weak entity set it is many, right? And this relationship is called as identifying relationship and this is depicted using this double diamond. Okay, so weak entity set is depicted using double rectangle. The identifying relationship set is depicted using double diamond. This is double rectangle and this is double diamond. Okay, and the important point to be noted is the identifying relationship is having always the cardinality 1 to many, 1 towards the identifying entity set and many towards the weak entity set. Identifying relationship is the relationship between the weak entity set and the related identifying entity set. Relationship between weak entity set and the corresponding identifying entity set is known as the identifying relationship set. And the properties of identifying relationship set are, it is always having the cardinality 1 to many, 1 towards identifying entity set and many towards weak entity set. Also, Also, one more important concept that we may note here is the weak entity set is always having total participation in the identifying relationship set, and the reason is the section here in this situation, this weak entity set is existence dependent on the corresponding identifying entity set. So always every entity in the weak entity set must participate in this identifying relationship set, and that is why this participation of weak entity set in the identifying relationship is always total. Now, the next concept, this is the entity set, okay, and we would like to distinguish the entities stored in the weak entity set that depend on a particular strong entity. So as I stated earlier, every course is having its own section 1, and it may happen that the same section 1 is being taught in the same semester and same year. Correct? So I want to discriminate between those sections taught in a particular semester and taught in particular year, right? So under every course, I want to distinguish among the entities stored in the weak entity set. So all the entities those are stored in the weak entity set depend upon a particular strong entity that is stored in strong entity set associated, right? So the attributes of a weak entity set, those actually help me to distinguish among the entities in the weak entity set. Those depend on a particular entity in strong entity set. These attributes are known as the discriminator attributes, or it is also known as the partial key. So here, for this weak entity set section, I am having the partial key or the discriminator key, and this key is the combination of these three attributes. Combination of these three attributes, section ID, semester and year. Right? So we have depicted those discriminators or the partial keys. Those belong to my weak entity set with the help of this dashed underline. So these are not primary keys because weak entity set is not having its own primary key. But my weak entity set is having the partial key or the discriminator key. And what we mean by this partial key or the discriminator key? This key actually is helping me to distinguish among the entities those depend on the same strong entity, right? So if I am having, say, course ID CS101, so if I am having this course ID CS101, I am having several entries in this weak entity set section. Those depend upon this CS101. So if I am having 1, 2, 3, 4 entries in this section, those are related to CS101. So what I need to do is, I need to distinguish these 4 individual entities. Those depend upon this particular course. So if I want to distinguish these 4 entities stored in my weak entity set, I need to have some attribute or some set of attributes. Those will help me to distinguish. Roll number 323.
Yes, ma'am.
Have you understood whatever I explained?
Yes, ma'am.
So what is discriminator or the partial key?
It is the discriminator is of a weak entity set that distinguishes among all entities of a weak entity set which depend on a strong entity set.
Yes, correct. So if I am having 4 entries in my weak entity set, those depend on a particular strong entity set. So particular course is having say 4 different entries in my weak entity set. Then under that particular course, I need to distinguish these 4 entries from one another. And the attributes or the set of attributes, those actually are helping me to distinguish among the entities of a weak entity set that depend on a particular strong entity set. This combination of the attributes is known as a partial key or a discriminator, and the discriminator is depicted by making use of dashed underline. Okay, and if I want to form now a primary key for the weak entity set, then how I am going to form the primary key of the weak entity set? The primary key of the weak entity set is formed by making use of the primary key of the identifying entity set associated. So, existence of this weak entity set is due to the associated identifying entity set. So if I want to form a primary key for this weak entity set, I will simply add the primary key of this strong entity set associated with it into this weak entity set, and this will give me the primary key for weak entity set. So once again I am highlighting the concept. The weak entity set is not having its own primary key, but it is having the partial key or the discriminator, right? So if I want to form a primary key for the weak entity set, what I will do? I will use the partial key of the weak entity set along with the primary key of the strong entity set associated, on which the existence of this weak entity set depends. Right? So this will give me the primary key of the weak entity set. So in this typical example, what is the primary key for the section which is weak entity set? The primary key of the section is the discriminator for the section or the partial key for the section. In addition, the primary key of the identifying entity set. So primary key of the section is course ID, section ID, semester, year. Because these 3 attributes are forming the partial key. So partial key along with the primary key of the course will give me the primary key for the section. That is the weak entity set. Have you understood the concept?
Yes, ma'am.
Let us summarize the things.
Ma'am, will you repeat?
Yes.
Hello.
Yes.
Ma'am, will you repeat?
Okay. Okay. So see here, as I mentioned, our weak entity set is not having its own primary key. But if we want to create a primary key for the weak entity set, how we are going to form the primary key for the weak entity set? Primary key of weak entity set is the combination of the primary key of the identifying entity set, and the partial key of the weak entity set. So in this particular example, section is my weak entity set having the partial key described with these three attributes: section ID, semester and year. So to form the primary key of section, I'll be making use of the partial key of its own plus the primary key of the identifying relationship, that is course. So primary key of my section would be course ID, section ID, semester and year. Right? So here the discriminator of section is section ID, semester and year. So that is the discriminator for this entity set section, which is weak entity set, right? And the primary key of the course is course ID. So I'll be coming up with the primary key of this section as combination of my partial key plus the associated primary key. Okay, so these four attributes in our example will form the primary key for the section. Correct? Any doubt? You understood?
Yes, ma'am.
Yes. May I proceed now? May I proceed?
Yes, ma'am.
Okay. So now let's note few important points. And what are those few important points? As we have seen here, the primary key of the strong entity set is not explicitly stored with the weak entity set. Just look at it. We are not going to store this course ID with this weak entity set. We do not have any attribute course ID that is being stored with this weak entity set. With weak entity set, we are storing only the discriminator or the partial key, right? And as this is the weak entity set which is associated with the respective identifying entity set via this identifying relationship set, the primary key of the strong entity set is implicitly available, okay, with this weak entity set, right? So please note that the primary key of the strong entity set is not explicitly stored with the weak entity set because it is implicitly there, right? It is implicitly there via this identifying relationship set. Are you getting me? Yes. This course ID, which is the primary key of the strong entity set associated, we are not explicitly storing this course ID with this weak entity set, but this course ID is implicitly available to the weak entity set via this identifying relationship. Got it? Yes?
Yes, ma'am.
Okay. So you please note down few important points as well. Okay. So I have not depicted those points or I have not mentioned those points on this screen or this slide, but you should understand or you should have a note of these points, right? So I am having some comments or notes related to weak entity sets, and those I am describing here. Please have a note of all those points. Okay. So, a weak entity set can participate in relationships other than the identifying relationship. I'll repeat. A weak entity set can participate in the relationships other than identifying relationship. What we mean by that? See, with this weak entity set, we are having associated this strong entity set, right? And this association is depicted via this identifying relationship. Okay, and we must have this identifying relationship with respect to any of the weak entity sets. But now what I am stating is the weak entity set can also participate in the relationship set with some other entity set as well. So it is possible that this weak entity set is participating in few more relationships, right, other than this identifying relationship set. Have you understood? Yes. So in this particular scene, I may have, say for example, this entity set, say time slot, right? So what we mean by this time slot? Every section of the course is delivered, right, in a particular time slot. So I need to relate this section with the time slot. So if I want to relate this section with the time slot, I'll be making use of some other relationship as well, right? So I'm having a general statement here that a weak entity set can participate in the relationship other than the identifying. This is identifying relationship. So other than this identifying relationship, it is possible that weak entity set is participating in some other relationships as well. Have you understood the concept? Yes?
Yes, ma'am.
Fine. Now, one more concept that I am going to illustrate. It is also possible to have a weak entity set with more than one identifying entity sets. I'll repeat. It is also possible that the weak entity set is associated with more than one identifying entity sets. What we mean by that? See, for example, this weak entity set section is dependent on course, right? But it may also happen that this weak entity set is also existent dependent upon some other strong entity set as well. So what I mean by that? See here, I am having one more entity set, which is strong entity set, right? So it may happen that the weak entity set is having associated with more than one strong entity sets. Those are actually the identifying entity sets for this weak entity set. In other words, I may say that one weak entity set may be existence dependent on more than one strong entity sets associated. It is also possible. So in that situation, to have the existence of the entity that is stored in weak entity set depends upon two entities, one that belongs to this strong entity set and also another entity that belongs to another strong entity set associated. So if in this situation, if I want to find out the primary key of the weak entity set, what I'll do? I will have the combination of the partial key of the weak entity set plus the primary key of this particular strong entity set that is associated, and also the primary key of the another entity set that is also associated as the identifying entity set. So I'm once again emphasizing the point, one weak entity set may be existence dependent upon, so depending on the need, depending on the problem statement, we are supposed to make use of all those concepts, right? So I hope you
Yes.
must have understood. May I proceed?
Yes, ma'am.
Fine.
Yeah.
Okay. So let's proceed now to the one more example of weak entity set. It is a simple example once again that has been depicted to have the clear idea of the concept. So see here, we are having one entity set that is employee, right? And every employee is having some dependents. So dependents are the people who are dependent on that particular person, right? So usually whenever we are having, or usually it happens that many times we need to provide the information about the dependents who depend on us, right? So if I want to model such kind of a thing, what I can do is I can have dependent as the weak entity set that depends upon the strong entity set that is employee, right? And here for this weak entity set, I have depicted name as the discriminator or the partial key. So what I mean by that partial key? Say suppose if I am having employee ID 1 and if this employee ID is having say two dependents. So how these two dependents are being differentiated under that employee ID 1? Say for example, employee with employee ID 1 is having two dependents. And who are those two dependents? Maybe one dependent with the relation wife and another is the daughter. So these two people are dependent on a particular employee with employee ID 1, right? So under relation, I'll be mentioning the relationship of that dependent. But under that employee ID, if I want to discriminate these two entries of the dependents, I'll be making use of name, right? Because obviously, why I'm making use of this name as the discriminator? Because obviously, under that particular employee ID 1, I'm having all the dependents with different names. It may not happen that the wife of the person and the daughter of the person are having same names. Correct? No? So this is a simple practical example. It may not happen that wife and daughter of employee are having the same names. So I can make use of this attribute name that discriminates between the dependents, right? But it is possible that two different employees may have the dependents with same names. It is possible, right? And that is why for dependent I am saying name as the partial key, right? And to form the primary key of this dependent, I am using now the primary key of the employee, that is ID along with name. So ID along with name will be used as the primary key for this weak entity set, that is dependent. So please note a small correction here. Dependent is the weak entity set that depends upon the strong entity set, that is employee, via the identifying relationship set related. So here the participation of dependent in the identifying relationship set related must be total participation. So please note that the weak entity set participates in the identifying relationship set with the total participation. With the next concept, I am going to just introduce the concept, and in the next session we will be having the at length discussion related to these concepts. Okay. So under extended ER features, we are going to cover three important concepts, and those are specialization, generalization. In fact, these two are very much similar and related concepts, specialization, generalization. And the another extended feature that we are going to talk about is the aggregation concept. Okay, so let's begin with specialization. So we know the meaning of the word specialization. So what does this mean, specialization, or what does this word mean, specialization? See, for example, suppose I am engineer, right? So the general category in which I belong is engineer, right? But I may say that though I am engineer, I am having this specialization, that is computer science and engineering. Correct? So if I belong to the category that is engineer, right, I am having some unique property, and that is due to my specialization, that is computer science. Fine. So what I have stated is we are having some general category and we are having some specialization under that. Similar kind of concept we can depict by making use of ER model or ER diagram, right? So specialization is typically a top-down design process, right? So under specialization, we are designing or will be having some subgroupings, right? So we are having some main group, and under that main category, I am having some subcategories or some groupings, right? So I may have some one main entity set, and that main entity set, I'll be having some subgroups, sub-entities, right? And how I'm going to differentiate or how I'm going to form these subgroups based upon some peculiar characteristics of the entities, right? So specialization is the top-down design process wherein we are having some main entity sets, and under those main entity sets we may have some subgroups of the entity sets, and these subgroups of the entity sets are formed by making use of some specific characteristics of those entities, right? So whichever are the subgroups of the main entity set, those become the lower level entity sets, and those lower level entity sets are having their own attributes, and they may participate in the relationships. Those are not the same that of their owner entity set. So I'll give you one example. Okay, So if you look at this figure, suppose in our university database, we are having many different people, those are working. Okay, so I'm having the employees, I'm having the students, I'm having the instructors, and so on. So lots of persons are working in our university. Okay, so what I can do is I can have person as the generic entity set, person. So what are the attributes of this person? I may have the attribute for this person as ID, which is the primary key. So every person is having unique ID. So that is the primary key of the person entity set. The person is having name, the person is having address. So these are the common attributes. Those every person must have. Okay, but now I may categorize those persons, I may group those persons depending on some typical characteristics, some specific characteristics. So for these persons, I may have the lower level entity sets like employee and student. So I may say that student is a person, or I may say that employee is a person. So here I am having all those attributes of the higher level entity set available to the lower level entity set. I'll repeat. I am having all the attributes of the higher level entity set. Those are available to the lower level entity sets. So employee and student are the lower level entity sets and person is the higher level entity set. So all the attributes are person, all the attributes of person are also applicable to employee and student. Why? Because employee is a person and student is also a person. So whatever are the attributes of the person, those are also applicable to employee as well as student. But in addition to these attributes, I may have few more attributes related to that kind of entity. Say for example, if the person is employee, then the person or the employee is having additional attribute, that is salary. Okay, the person student is having the additional attribute, that is total credits. Right? So the lower level entity sets are having their own attributes. Those are describing the additional properties or additional characteristics. Right? So the attributes from the higher level entity sets are inherited by the lower level entity sets. But in addition, the lower level entity sets are having their own attributes. Okay, and now this relationship between the higher level entity set and the lower level entity set is depicted by making use of such kind of a triangular component. Right? And this component is labeled as ISA. Right? So we may say that this is ISA relationship. So this higher level component is related with the lower level components with this kind of a triangular notation, and this is labeled as ISA. And how we are going to read this? We are going to read this like employee is a person, student is a person. Right? And as I stated, the lower level entity set inherits all the attributes from the higher level entity sets. Also, the lower level entity set inherits the relationships also, in which the higher level entity set is participating. What I mean by that? Suppose person is participating in one of the relationships with some other entity set. Let us assume that here I am having the entity set, say department, right? So person, which is the higher level entity set, is related with this other entity set, that is department. Okay? Below this person, I am having several other entity sets, lower level entity sets. Okay? So what I am saying is, similar to how these attributes are being inherited by the lower level entity sets, the relationship in which this higher level entity set is participating, obviously these lower level entity sets also participate in that relationship. What I mean by that? Person is associated with the department. So obviously every employee who is a person is related with department. Every student who is a person is also related with the department. Correct? Very simple logic. Okay, so attributes are inherited by the lower level entity sets, and also the relationships in which the higher level entity set is participating. Obviously, those relationships are applicable to the lower level entity sets. Okay, now similarly, we may extend these concepts to few more levels as well. So once again, I may say that employee, here employee is depicted with the separate attribute salary. Now, I may have once again the types of employees. So, instructor is employee, secretary is also employee. So, I may further have the subgrouping of employee like instructor, and also I am having the subgrouping of the employee as secretary, right? So I may come up with these two entity sets, instructor and secretary, under employee. So what I mean by that now? This means that employee is inheriting all the attributes of person, right? And employee is having its own attribute salary. So if I'm having one more lower level entity set under employee, right? Instructor may have its own attribute. Along with that, instructor is inheriting the attribute from employee, and in turn the attributes of person. And similar is the case for secretary. So whichever are the lower level entity sets, those are having their own attributes, and also they are having all the attributes, those are inherited from their upper level or higher level entity sets. Are you getting me? Yes. Roll number 351. Akshata. Roll number 351.
Yes,
Are you
ma'am.
there?
Yes,
Have
ma'am.
you understood the concept?
Yes, ma'am.
Okay. So, what is specialization? Can you repeat what is specialization, Akshata?
Yes, ma'am.
So it is,
Specialization is a top-down design in which we make a subgroups, and the whichever is at higher level, the properties of that higher level entities is inherited to the lower level subgrouping entities.
Yes,
For, for example, here secretary is an entity which is inherited from the employee, and employee is another entity which is inherited from the person. That's why secretary has the attributes of itself as a hours per week, has attributes of employee as salary, and has also has the attributes of person as ID, name, and address.
correct. And very good. And in addition, if the higher level entity set is participating in any of the relationships, right, then the same association is applicable for all the lower level entity sets. Correct?
Yes, ma'am.
Fine. And this kind of association is depicted by making use of a special notation in ER diagram, and that is a triangular notation like this, which is labeled as ISA. So we say that it is ISA relationship, and we call it like the lower level entity set is of a kind of a higher level entity set. So we say that employee is a person, student is a person, instructor is an employee, secretary is an employee. Correct? We may have under student similar kinds of categories. So I may say that we are having the categories under student like the UG student, undergraduate student, or maybe the graduate student, right? So these are the categories of the student. So I may say UG student is a student, or the graduate student or a postgraduate student is also a student. So I may have this is a relationship under student also. Is that correct?
Yes, ma'am.
So I hope you must have understood this concept of specialization, right? So I'm just going to introduce now the generalization and then we'll stop. So generalization, as I stated, is the similar kind of concept, but specialization is a top-down procedure, whereas the generalization is the bottom-up procedure. Right? So in generalization, what we do, we combine the number of entity sets together. Those are sharing some same features, and we form the higher level entity set. In specialization, what we do, we begin from some higher level entity set, and based on some distinguishing properties, we go on grouping those entity sets. So it is a top-down procedure. Whereas in generalization, what we do, we go from bottom to up. So we are having some specific entity sets, but they have some common features, right? So what we do, we group these different entity sets and we come up with one higher level entity set with these common attributes or common features, right? So only the concept is different. Specialization is a top-down process, whereas generalization is a bottom-up process. Is that correct? So as I stated, in specialization, what I said, engineering is some generalized thing. So I am engineer, so some generalized properties are assigned to engineer, but I may have this specialization like computer science. But now what I am saying, I am having computer engineers, I am having electronic engineers, I am having mechanical engineers, right? So these computer science, mechanical, electrical, electronics, these are having some specialized characteristics of their own. But all they belong to the generalized category, that is engineer. So we are having initially those specialized entities. So we pick up the common attributes from all those entities and we form the higher level entity, that is engineer. Right? I hope you are able to understand the concept. In fact, if we relate this generalization process with the ER model, there is no difference at all in drawing the ER model. Okay? Only thing is, in case of specialization, we start the design from this person and we go on splitting the person, we go on grouping this entity person into different entity sets. Whereas in generalization, what we do, we identify first that there is instructor, there is secretary, and then we come to know that instructor and secretary are actually the employees. Right? So we collect the common features of instructor and secretary and we come up with the entity set employee. Right? So we have identified now this entity set employee. We are having another entity set identified, that is student. But now we say that employee and student are also sharing few of the common attributes. So why not to come up with one higher level entity set, that is person. So we come up with this person. So this is a bottom-up process, whereas specialization is the top-down process. But as far as the ER modeling is considered, we come up with the same kind of design ultimately, even though it is a bottom-up process or a top-down process. So you may say that specialization and generalization are simple inversions of each other. Right? If you have any doubt, please. Yes. Any doubts? Yes. Any doubts?
No, ma'am.
Fine. So we are going to conclude today, right? And we are going to continue the same concept of specialization and generalization with few more details. And also, in the next session, we are going to cover the concept of aggregation. Right? So I think, or probably we are going to conclude this unit number 1 in the next session. Right? So if you have any doubts, please let me know. Otherwise, I'm going to conclude and you'll be having one quiz today. So I'll be posting the link for the quiz. All are supposed to respond for the quiz. Okay? Is there any doubt?
No, ma'am.
Fine. So let's conclude. Thank you.